Hi students, welcome to our YouTube channel again. Today our topic of discussion is calculating mass of reactants and products. So in this topic and in this video I will show you some tricks in which you can find the masses of the reactants and the products easily. Okay, so you have to remember like some steps while calculating the masses. Okay, like for example I am going to write step 1. So the step 1 is, first you have to convert the mass that is the already present. Okay, that mass may be of the reactant or maybe of the product, that is the given mass. Okay, you have to convert the mass into moles. That is your first step. The second step, step 2, that is you have to compare the molar ratio. Molar ratios of the reactants and the products. And now the step 3. The step 3 is, now after comparing the molar ratios, and then you can convert the predicted amount in moles into mass. So again the next one, that is you have to convert the new moles into mass. Okay, like for example I am going to show you here. That are the 3 steps. These are the 3 steps in which first the measured mass or the given mass of the substance, okay, into moles of measured substance. Then that is the second step in which you can compare the molar ratio, and after comparing the molar ratio then you can indicate like what are the new moles or what are the moles of the required substance. And the third step, that is mass of required substance by using moles, and then you have to times by its molar mass. Okay, now I am going to solve here the problem, then you can easily understand these 3 steps. Okay, the question is, iron is mostly used in iron is mostly or most widely used metal in North America. It may be produced by the reaction of iron 3 oxide from iron ore with carbon monoxide to produce iron metal and carbon dioxide. What mass of iron oxide is required to produce 100 grams of iron? First, you need to write the equation. The equation is iron oxide, that is iron 3 oxide, so here is Fe2O3, react with carbon monoxide, so it will form iron and carbon dioxide. Okay, now you need to balance this equation. So you can see here are the 2 moles of iron, here is 1 mole, so here is the 1. It means like here are the 2 irons in iron oxide while there is only 1, so it means you need to write here 1. And next, like while comparing or balancing the oxygens and carbon, so you can see here on the left side there are 4 oxygens while on the right side there is only 2, so it means you need to balance it. So while balancing, when we put here 3 and here is also 3, it means now the oxygens are 6 and here the oxygens are also 6 and carbons are balanced. Okay, now in this question we have 100 grams of iron, so the required mass of iron, that is M1, is equal to 100 grams. Okay, so as you know that over step 1, that is convert the mass into moles. So for conversion, we need the molar mass of iron. Let's suppose I am going to write M1. The molar mass of iron, that is 55.85, okay, grams per mole. Now what will be N1? N1 is equal to, as we know that here, like mole is equal to mass divided by molar mass. So here 100 divided by 55.85. Okay, so N1 will equal to, let me calculate it. So 100 divided by 55.85, and you got 1.79. Okay, so that is for M1. You can see here, okay, the moles of iron. Now the step 2, you need to, sorry, here I did mistake. Actually there should be 2 irons, because here is the 2 irons on the left side, so there should be 2 irons on the right side as well. Okay, now you need to compare the molar ratios. Okay, here now the step 2, that is comparing the molar ratio. So molar ratio by using the equation. So you can see here, the iron, that is 2, while the iron oxide, that is 1. So it means you need to divide it by 2 to get divide by 2, because the molar ratio is 1:2 or 2:1. 2 is for the iron and 1 is for the iron oxide. So it means you need to divide by 2 and multiply it by 1. Okay, so here when you divide by 2, then N2 will equal to 0.89. Okay, while in the case of like iron oxide, so now you need to find the mass. So it means the step 3, that is by using the moles, we can easily find the mass of iron oxide. So for the mass of iron oxide, we need to find first the molar mass of iron oxide. So the molar mass of iron oxide is 159.70 grams per mole. Okay, and now the mass will equal to, as you know that the mass will equal to moles times molar mass. So it means M2 will equal to, here multiply by 159.70. So that is about 142.9, or you can write here 143.0 grams. Okay, so that is the mass of the reactant that is used to produce iron. Okay, so that is a short video in which you can easily find the mass of any reactants, whether the any substance, whether that may be reactants or that may be products, by using or by following these 3 steps. Okay, so that is the easy trick in which you can find easily. So I think you would like our video. If you like it, then kindly subscribe us and share our channel. Thank you. We'll see you in the next video.